Hey folks, it's Eugene here and welcome to Click3D. This is the program where we talk about all things 3D. We talk about laser scanning, we talk about photogrammetry, we talk about hardware, we talk about software, and every now and then we do an interview as well. Most of you know, if you're working in this space, that you have to deal with a ton of data and you have to store that data someplace. And sometimes you have to archive it and then pull it back out. You'll know that it's a real pain in the rear. Now, some of my friends that do a lot of photography talk about, how many photos they have and how many gigabytes they got to deal with. Well, if you've been doing this for some time in the 3D space, you're talking about terabytes of storage, not gigabytes. Sometimes larger projects can already be hundreds and hundreds of gigabytes just for one project. So, many people store their stuff on a local server, maybe on a backup drive. And if you know what Dropbox, OneDrive, and Google Drive do, then this is what Stitch3D is. It's sort of a storage place for data, but it also allows you to view scans, it allows you to measure, and it allows you to share and collaborate. So, without further delay, we're going to be speaking to Clark Yuan, who is the founder and CEO of Stitch3D, and he's going to tell us about what Stitch3D is all about. First thing, Clark, thanks for being here. And I want to ask you, so can you give me a little bit about your background and how you got started on this whole Stitch3D thing?
Sure. Yeah. Great to be here, Eugene. So I was formerly an Army intelligence officer, served for 7 years on active duty, looking at a whole range of, aerial imagery intelligence, up to satellite imagery, LiDAR imagery. When I left active duty, I was actually working with a Navy research lab out in San Diego. And this lab was using LiDAR data to document damages to naval facilities, ships, and assets, whether it's from storms, whether it's from fires, or sometimes even, battle damages. The issue that the Navy lab ran into when I was working with them is that they had a really difficult time of sharing the LiDAR data on a cloud environment with their colleagues. So they were literally burning Blu-ray discs and external hard drives and shipping that data physically to their clients, which are the units out in the field. So they asked me if we can, create some sort of prototype, build it on the cloud. They provide the R&D for it, and they wanted to use it for obviously military purpose. But then we discovered that, as LiDAR was becoming more and more commercially available, that this is actually a big problem just across the industry.
Okay, about what year were we talking about? Like when you were asked to do this for the military?
Yeah, this was the summer of 2020, right in the height of COVID.
Okay, yeah. So it's not. I mean, not that long ago. I mean, it was still pretty recent, and there maybe were some other solutions, but obviously, I would assume the Army wants their own system in place so that they can, for security and that sort of thing, right?
That's right. Yeah. For the military, you have to be compliant with, cybersecurity requirements to be operational on the DoD network. So fortunately for us, once we received the R&D contracts, the NSA is actually helping us with some of our cybersecurity requirements, which allows us to be compliant with DoD protocols and allows the military to use our product.
Okay. So, and I know some people in the military. So we're talking about like things like aerial LiDAR, maybe like terrestrial LiDAR too, like people actually scanning with terrestrial LiDAR scanners, or what was the makeup of the source of all this data?
The collection method, honestly, was not, it wasn't very material as far as like how the military got the data. We've used drones, we've used handheld SLAM-enabled technologies, we've used terrestrial tripod-based LiDAR sensors. For example, we've even used a vehicle-mounted sensor to capture runways. So it just kind of depends on the use case, right? The military has a requirement document facilities, which might be better with a SLAM-enabled technology, capturing large terrain. That might be better with drones. And of course, roads, conditions, things like that would be better for a vehicle-mounted sensor.
Okay, so at some point you said, "Hey, I'm going to take this technology or take this stuff and make it into a company and offer it as a service kind of thing." So was that when did that happen?
That happened shortly after the summer that we were working with the Navy lab. We spent about 4 months working with them, and then we were doing market discovery on the side, talking to users, and realized that a lot of folks right now are using just your traditional cloud storage platforms. Google Drives of the world, OneDrives of the world, and it just wasn't compatible with 3D data. And so shortly after working with the Navy lab, we decided that there was an opportunity here and we wanted to explore, where it could go. So that was around October 2020.
Okay. And so tell me about Stitch3D then, and kind of like how it operates and how it's set up and how it works.
Yep. So on one part of Stitch3D, and probably the most value that users will get out of it, is the ability to collaborate on the web through a lightweight browser and with decent Wi-Fi with point clouds. You can take a large, 50 gigabyte file, 100 gigabyte file, put it on the internet, and once it's on there, people can, add tags, people can have discussions, and that collaboration feature is really what's key to the entire ecosystem that's kind of missing right now. The other aspect of it is having a fast 3D web visualization that you can add measurements to, annotations, being able to crop, see different classifications. So some of the bare essentials for making 3D intelligent, we're providing that also on the web. So we're not trying to build the ArcGIS for the web. We're not trying to build every tool that people would want to see, but the most simple basic tools like distance, area, volume measurements, being able to classify the environment, being able to crop, being able to map, things like that.
Okay. I mean, you have I know you got a demo set up. Could I show that here?
Sure.
Yeah. Let me just bring this up on the screen, and maybe you can walk me through a little bit about your system and how the user would be presented with like an interface and such.
Yep. So you can see the interface is actually very similar to like a Box or a Dropbox. You can upload, and currently we support LAS files, LAZ, E57, PLY, OBJ files. Once you upload it, there's actually a conversion process that happens, and it converts it to a cloud optimized format. And that's what you're seeing here on the platform. And Eugene, actually, I'll show you some of the data that we've actually collected from Recon 3D using your sample data, just to show what that looks like here. Because we've also used a lot of, we use the iPhone LiDAR for a lot of our data sets as well. So for the police use cases, let's look at traffic accidents. Let me pull up this one.
So the idea though is, somebody has an account, they can take all their data, they just upload all their 3D data, whatever format it is. And then if they want to share a link to that data with somebody else who has an account as well, they could get that data, they could, fire it up and see it in 3D, annotate it, do some different things, and then send it back.
Yep, that's exactly right.
Okay.
Yep. So this is data that you've collected off of your app. So you can see here, if you turn on the adaptive mode and it kind of fills in the gaps, you can almost get that photorealistic quality from just using a LiDAR sensor alone. And then from here, what's important for, emergency responder or policeman, highway patrolman, is just being able to quickly send this back to the office, get some measurements. You can do distance, you can do height, you can do, square footage. Yep. And this would also be very important information for an insurance company to look at as well. And maybe you can say like, Note 1, vehicle traveling 80 miles per hour. And so now you can have a conversation with someone on this point cloud itself, and you would be able to share it and save it and distribute it, and also set permission levels for who can view and download it as well. So
okay. In terms of file size though, like how large of a point cloud are we talking about that you could bring in? Like, is it, do you start seeing a slowdown at a certain point?
Yeah. So this one is in the megabytes, how big was this?
Yeah. This one here, I don't think was that big. It might've been like,
about 82 megabytes. Mm-hmm. So we've done everything up to, like 50 gigabytes. So I'll show you this one here. This is a high school. So theoretically, as long as you have the patience to wait for the upload speed, you can upload anywhere up to a 250 gigabyte file.
Okay.
So this will take slightly longer to compile, but it should show up here in a few seconds.
So can you explain sort of what it's doing in the background, like or how you're displaying, or what kind of technology you're using to display the point clouds?
Yep. So currently it's a refactorization of Poetry, which is an open source library that's pretty well known for developers. What we basically did with Poetry was we took it and we broke apart the entire code base. And it's a massive library, and we basically had to recode some of the database so that you can actually see it and compile these imageries a lot faster. Because if you were just to take a straight Poetry copy and paste, it would actually be quite slow and wouldn't function as well for what we're trying to do. And for this, some of the features that we liked about Poetry was being able to slice and crop, being able to rotate, but we had to make that work for our own platform.
I see.
Yeah.
So when it loads, so it breaks it up into like smaller chunks, and then you can see like when it's loading, it's almost like they used to do with like level of detail or something like Octree, break things up into like smaller groups, and you load what you need and you kick out what you don't.
That's exactly right. Yeah, we break it up into octree tiles, and actually, as I zoom in, you'll be able to see that kind of in action here. You see these little tiles loading, and the more you zoom in, the more precision and quality of the data you'll see. But again, it's only as good as the sensor. So if it's not a very dense point cloud to begin with, the point cloud isn't going to load that detail. But this one's pretty good.
Yeah. And so you got measurements, you got annotations, and then so when the user does that, they just like save it, and then it can show up for somebody else.
That's right. Yeah. And so another feature is being able to, crop the point cloud. And so if you want to look at a floor plan and, take a look at it like top down, something for, law enforcement and for fire is being able to quickly see the floor plans of a school. So you can look at elevation mode. Okay. So now you have essentially, like the first floor plan. And these are measurements that are accurate down to centimeters. And so you can actually create measurements and say you want to measure the length of this hallway. You can do that. And then you can actually just save this view. Let's say this is the first floor plan, save that. And then, so if you were to reslice this and take it up, a floor perhaps. So now you have your second floor plan.
Sure.
Let me just change the elevation on this real quick so you can see this.
Okay, so you get like your thresholds there, like just like you would do like with contrast or brightness or something like that, except these are colors, so like a color ramp.
That's right. Yeah, this is elevation. So you can see, like areas of higher elevation is going to be shaded in red, and then areas of lower elevation is going to be blue. But you can also switch it back to the RGB view if you'd like. And so going back to that floor plan that I just captured, if you were in this view and you want to quickly go back to first floor, you can go back and see the first floor because it's already been saved as a view.
Yeah, it looks pretty cool. What's going on with the lighting, the type of lighting that you're showing? It's, obviously there were colors and things like that, the different saturation, But is there like different lighting modes in this right now?
Not currently. So currently we just have one standard default shader for the entire point cloud. But eventually we want to be able to add in like shadows and make it look more realistic. Something that the product team is discussing is being able to add in like weather conditions. So if you were looking at something that was outdoors, if it's like a foggy day or if it's raining, you'll be able to actually see the effects of that shading on the point cloud.
Yeah, I can see. And again, I can see like companies and bigger agencies that are doing a lot of scanning, wanting to keep a repository of everything that's quickly accessible that they can share with different people. So that's kind of neat how you have that. Now, you're kind of dedicated to 3D data, but I'm just curious, like, is it just, you said LAS, point cloud and stuff like that, but have you guys thought about things like OBJ models or textured meshes and things like that too?
Yep. So you can currently upload OBJ files into our platform. We're still working through some of the bugs with OBJ, but that is something that you can currently do. Eventually, I think we'll want to expand into like STL files. Things are not just like straight point clouds. Maybe something that's compatible with 3D printing or something that's compatible with augmented reality. But for right now, since we're still a startup trying to get the public beta off the ground, we're just focused dedicated on point clouds from LiDAR sensors, especially for now.
So how does it work? Somebody goes to the website, they can sign up. Do they pay for a month, a year, a certain level of a certain amount of data? Like how does it work?
Yep, there will be a per user fee per month, and then with that fee you get up to say like 50 gigabytes of free upload. And then if you want to go above that, then it's kind of a pay as you go by buckets. So if you want to get up to like the next tier, which is 100 gigabytes, there's a price involved with that. And if you want to do 500 gigabytes or a terabyte or 5 terabytes, then it's kind of just pay as you go. So you're not just paying for a straight flat fee.
Okay. My last question, what is the next big thing you're working on your platform? I don't know if you can say or not, but if there's anything, what's sort of the next big step for you guys in terms of research or development?
Yeah, I think the big one is, that simulation of weather data based on like terrain environment information. So something that's, I think, really cool for us is if you were, maybe I can just show you this. If you had a point cloud that's been geo-referenced, and most of the data sets that we get back from drones are geo-referenced, you can actually align to a base map. So for this, if you were, tracking wildfire damage to the Pacific Northwest, or if you wanted to look at road conditions after it rained, we can actually map this to a satellite map. And the next step would be then to embed weather, like real-time weather information, and see how like a washout of a road might affect the conditions to get up a mountain or something like that. So You can see this is aligned pretty well with where it is. You can still do kind of like the elevation view and the cutouts. Yeah, but the next step would be to take this and say, we know that this is 12-degree incline. But what does a 12-degree incline look like for operations when there's been a storm the night before? Like how much mud do we anticipate having? And so just like embedding some of that real world analytics into the point cloud itself.
Excellent. Well, I'll tell you what, I love the simplicity of it. It looks really, really streamlined, really simple, and looks like it's working really well here. So look, I want to wish you all the best of luck with this thing. And yeah, we'll definitely be in touch. I'll keep following up on how you guys progress.
All right, Eugene. Yeah, thank you so much for having me on the show.
All right. Cheers, man. Take care.
Okay. Thank you.